Let us try and solve this question. Express 3x plus 7 over x squared minus 5x plus 6 minus 3 over x minus 3 as a single fraction, and hence find the values of x for which the expression is undefined. So there's a question. Normally, when we are giving algebraic expression like this with fractions, we look for the LCM, or the least common multiple, of the denominators. At some point in time, we also multiply the denominators, especially when they involve letters. But in this case, there's one thing that I'm going to do first. If it works, I'll continue with it. If it doesn't, then I can do another thing. This is a quadratic expression. I'm going to factorize this quadratic expression and see if I will find this denominator in it. This is what I've written here, x squared minus 5x plus 6. Now, when you are given a quadratic expression like this and you want to factorize, you first look at the coefficient of the x squared, or the value in front of the x squared. In this case, it's 1. Whatever value appears here would come and multiply the constant which is here, in this case positive 6. The coefficient of x squared here is 1. That's why you don't see any number here. So when is 1 multiplied by the positive 6, it's still positive 6. In this case, we are going to look for two numbers. When you multiply those two numbers, you'll have positive 6. When you add those two numbers, you have negative 5. Now, how are we going to obtain those two numbers? We are going to look for the factors of 6. When you look for the factors of 6, we have 1, 2, 3, and 6. And these are the pairs we are going to select from: 2 and 3, or 1 and 6. Whichever pair we select, when we add, we should have negative 5. And when we multiply, we should have positive 6. When we pick any pair, we could make one of them negative or both of them negative. In whatever way we negate them, we should be able to get positive 6 when we multiply the 2. And we should be able to get negative 5 when we add the 2. I would choose 2 and 3. When I make the 2 negative and I make the 3 negative, when I add them, I'm going to have negative 2 plus negative 3, which is the same as negative 2 minus 3, which gives me negative 5. When you multiply negative 2 to negative 3, you are going to get positive 6. So it means that the two numbers are negative 2 and negative 3. Now, this negative 2 and negative 3, I'm going to use them to replace the term with x. That's the negative 5x. So look at what I'm going to do. We have x squared already. Then the negative 5 is going to be negative 2x, negative x. So this negative 2x and negative 3x have been used to replace the negative 5x, because negative 2x minus 3x gives you negative 5x. So we have not changed anything. We've just replaced the negative 5x with two different terms involving x. So instead of negative 5x, we are having negative 2x and negative 3x. Then the last term here is a constant, which is 6. Introducing these two numbers would help me to be able to factorize this quadratic expression. Now, at this point, I want to look for the common factor. Now, the common factor of x squared and negative 2x is x, positive x. You bring it out, you bring the common factor out. Then you ask yourself, what are you going to use to multiply the x to give you x squared? You multiply x by x, or positive x by positive x, to give you what? Positive x squared. Now you ask yourself the same question. What are you going to use to multiply positive x to give you negative 2x? You will need to multiply x by negative 2, and that will give you negative 2x. Now when you finish factorizing the first two terms, what you obtained in the bracket, you leave a small space here and you repeat the same thing here. I've left a small space here and I've repeated the same thing here. Because I'm going to use the same thing for the next two terms. I've finished the first two terms, now I'm on the last two terms. Now ask myself a question. What would I use to multiply the positive x to give me negative 3x? Which number or what will I use to multiply the positive x to give me negative 3x? And it's negative 3. So put the negative 3 in that space. Then the last term will fit perfectly. Now, negative 3 times negative 2 gives you what? Positive 6. So it should automatically fit. Now, you see that we have two numbers in front of the brackets. Okay, we have the positive 6, we have the negative 3. And this negative x minus 2 is the same as the x minus 2 here in the bracket. So you pick the numbers in front of the brackets and put them in one bracket. So you have positive x and we have negative x. You put these two numbers in a bracket. Then this repeated bracket, you just pick one of them and you write it here. So we've been able to factorize this quadratic expression to obtain this. Now, look at something. You realize that this x minus 3 is here. So it means that this x minus 3 is inside this quadratic expression. Alright, now I'm going to solve this. This is now going to be 3x plus 7 over this. Because it's from this that we obtain this. So we are going to use this to replace that. So it's going to be over x minus 3 multiply x minus 2. Then we have this here. Now it's easy for you to obtain the LCM. Since this is a factor here, we can choose the whole of this as our LCM. So this is how our LCM will be. It will be x minus 3 multiplying x minus 2. Now this one goes into this 1. Then 1 multiplying 3x plus 7 will still give you 3x plus 7. Now in this case, x minus 3 goes into x minus 3 times x minus 2 how many times? Let me remind you of what you learned in your early stages. When we ask you, like let's say you were adding these two fractions and you obtain the LCM to be 6, you ask yourself, how many times does 2 go into 6? And you said 3. Now how did you get a 3? It is this divided by that. So it is 6 divided by 2 that gave you the 3. So that is 3, then that 3 comes to multiply this 1. How many times does 3 go into 6? It is 2. How do you obtain the 2? It is the 6, this one divided by that. And that gave us the 2. Okay, and the 2 will come and multiply the numerator here. So 2 multiplies the numerator here. And at the end of the day, we had 3 plus 4 over 6. And that gave us 7 over 6, which is an improper fraction. And that is 1 whole number, 1 over 6. Alright, so this happens the same way. How many times does x minus 3 go into x minus 3, x minus 2? It is x minus 3 multiplying x minus 2 divided by x minus 3. This cancels that and you have x minus 2. So x minus 3 goes into this x minus 2. And that x minus 2 is going to multiply the 2 here. And when you expand this and that, you are going to get 3x plus 7. And in this case, you have minus 3x. This negative is here, or this subtraction is here. I'm just using the 3 to multiply the x minus 2. 3 times x is 3x. 3 times negative 2 is negative 6 over x minus 3, x minus 2. This gives me 3x plus 7. This negative or minus will affect the 3x and also affect the negative 6. It is just like having negative 1 multiplying 3x minus 6 is the same. So x multiplying negative 3x will give us negative 3x. X multiplying positive 3x will give you negative 3x. Then negative multiplying 3x will give us negative 3x. The negative multiplying negative 6 will give us positive 6 over x minus 3, x minus 2. Now I'm going to group like terms. We have 3x minus 3x plus 7 plus 6 over x minus 3, x minus 2. Three x minus 3x is 0. 7 plus 6 is 13 over x minus 3, x minus 2. This is the answer when we want to express this as a single fraction. Then the next question was, hence, find the values of x for which the expression is undefined. Okay? When we say an expression is undefined, what we want to say is that we cannot obtain the answer, or it's a mathematical error. In terms of fractions, for example, if I have a over b and b is 0, we are going to get a mathematical error, or we will not be able to define this fraction when the denominator is 0. So if we are looking for the values of x that will make a fraction undefined, we are saying that those values that will make the denominator equal to 0 are the values that will make that fraction undefined. So if you are looking for the values of x that will make the denominator become 0 or equal to 0, then what we are saying is that our x minus 3 multiplied x minus 2 becomes 0. And from here, we would factorize to know the values of x that will make this denominator become 0. This denominator becomes 0. Now, if you have two numbers and they multiply and the value is 0, then it means that either the first one is 0 or the second one is 0, or both of them are 0. That is the condition that will make two numbers multiplying produce 0. Two numbers multiplying will result a 0 when the first number is 0 or the second number is 0 or both of them are 0. Alright, so it's either this one is 0 or this one is 0. So x minus 3 is equal to 0 or x minus 2 is equal to 0. This gives us x equal to 3, and this gives us x is equal to 2. So these are the values of x that will make this fraction undefined.